My name is Christophe from Almax Easy Lab. Our company is specialized into high pressure equipment, diamond anvil cells, piston cylinders and related equipment. We also provide some diamond anvils and diamond windows for specialized applications. In this short video, I would like to present you this specific product of ours, so-called the Helios DAC Plus, for high temperature and high pressure application. Nowadays, a lot of laboratories have the chance to have some X-ray diffractometer into their laboratories, and being able to expand the capabilities of this device by pressure is a welcome tool. This is the purpose of this cell: high pressure, high temperature for the Helios DAC Plus. This product is particularly useful for applications such as phase transition studies on minerals, be it organic or inorganic compound, but not only structural studies, but also more quantitative studies such as electron density studies. The specificity of this cell is a very wide aperture, be it at the front or at the back of the cell, with a total aperture of 80 degrees. Why is it so important for X-ray? Because effectively with such a wide aperture, the user can have access to a wider range of the reciprocal space in terms of diffraction patterns. So that's particularly useful for sample studies having a low symmetry in terms of structures such as monoclinic or triclinic structures. Unlike effectively some more standard diamond anvil cells which would not give you access to such large space. So let's take a quick look at the features of this cell. One of the main aspects of this cell is effectively its compactness. We had to design this cell to fit in a very compact space for X-ray, where sometimes space between the beam condenser and the beam stopper at the back of the cell is very limited. Here, our aim was to be able to fit that into a 60 millimeter space. Not only that, effectively, we've designed the cell in a shape such as it fits within a 58 millimeter sphere, such that the user can rotate the cell within this 58 millimeter sphere alongside the radial axis of the cell. Now, if we look at the different features of this cell, again, that's a cell which has been designed for temperature up to 900 degrees Celsius, for pressure up to 100 GPa, or 1 million times the atmospheric pressure. If we look at the bottom part of the cell, we can see a mounting pin here to be able to mount it onto the goniometer head. We can see two current leads to be able to power the internal gasket heater, and two small gas tubes enabling to flow some inert gas to prevent the damage of diamond anvils when we heat the cell above 400 degrees Celsius. At the front of the cell, you can see the gas capillary, which is also connected to the gas membrane, enabling the change of pressure while the system is onto the X-ray diffractometer. The weight of the cell is 438 grams. It's a substantial weight, and it's worthwhile checking with the manufacturer of the X-ray diffractometer the compatibility of this weight with the goniometer head. This device can be mounted on, for example, X-ray diffractometers such as the Bruker D8 Venture system, or the Rigaku Corporation Synergy or Supernova system, just to name a few. But it's a non-exhaustive list. It's important to bear in mind that when you use this cell, you need the connection with two gas supplies. As I said, a gas bottle which is going to fill the gas membrane for a pressure of up to 150 bar, and lower pressure inlet gas of 2 bar for the inert gas, such as argon, for example. So the complete system is effectively composed of the Helios DAC Plus with its two diamond anvils, an internal gasket heater, and a gas membrane. Here we can have a look at this internal part. So again, with compactness in mind, this internal gasket heater, where the gasket is mounted in the sample, the two electrical leads, which you can see again at the bottom of the cell. We had also to develop this flat gas membrane in the spirit of a very compact diamond anvil cell. So in total, such system is composed of the Helios DAC Plus, an external power supply such as the PS03, which comes also with its software, temperature manager, which allows you to control remotely the temperature inside the cell, and a gas controller system such as the IGM controller with its proprietary software, high pressure manager, also enabling you to control remotely the high pressure from a PC. Let's have a closer look to the inside of the Helios DAC Plus. Here you can find the gasket heater where you're going to position your sample, and underneath you can find the diamond anvil. Here you can find again the gasket heater, enabling you to heat up your cell, and you can find some features such as, for example, these 4 screws enabling you to rotate and align the diamond anvils. It's particularly important when you work at such high pressure of 100 GPa and very small cullet sizes, like in this case 150 micron. You can find the same diamond anvil onto the piston side. The diamond anvil is supported by an original combination of 2 types of seat. The first one made of tungsten carbide and the second one made of ceramic. This original feature is particularly important to ensure the thermal efficiency of the cell. Indeed, when we heat up the cell at temperature of around 600 or 700 degrees Celsius on the inside, these features mean that the outside of the cell remains at moderate temperature, such as 190 degrees or 120 degrees measured on the mounting pin. This is particularly important to keep effectively the integrity of your goniometer head. If you need more information about this product, this Helios DAC Plus, please do not hesitate to contact us, and our technical team will be happy to help you with your inquiry. Thank you for watching this video.